So generative design. Back in Creo 7, when we did this event last year, we showed the new generative design or generative topology optimization. Okay. So again, as I said earlier on, this is one of the reasons why multi-body was introduced in Creo, was to enable this kind of technology or this functionality. Okay. So GTO, as it's called, is there inside from Creo 7.0.0. So the idea is I can define my different volumes that I want to work with. The blue is stuff I have to keep, the red is stuff I have to avoid, the gray is whatever I can do with. I do all my setup, define all of my loads, my materials, my constraints, my conditions, run the optimization, reconstruct that geometry, and off I go. I can validate that. Okay, so all of that's done on your computer. So as we said when we launched this, the strategy for the generative topology was to enable cloud for that. Okay, so in Creo 7.02, which came out late last year, PTC added this generative design extension. So the idea of that is, I can run one set locally on my PC. So one material, one set of constraints, one set of loads, and I'll get a result, right? But really the point of this is to work out, well, what's the optimal solution? What if I make this out of 3 different materials and I have 5 different load cases? What are my options here? Okay. So if you do it on the desktop, you can only run one at a time. So that's a very iterative process. Okay. So the idea is to move that into the cloud, because the cloud is great at giving you compute power for this kind of stuff. So I would set up my study, upload that into the GDX running on the cloud, have it run all of the possible combinations of that, and then let me choose, looking at Pareto charts and other things, choose which ones I'm most interested in, start to filter them down, determine the one that I'm most happy with, send that back into Creo, and then off I go. Right, so that was introduced back in 7.02. So what's happening now with topology optimization in Creo 8? Okay, so if you're running stuff locally, if you're just doing that one by one, so now we use the process manager for that. Okay, so we can send one or more to that at a time. And the beauty of that is it's now been, we can see what's happening. We can see the status of that. So I can see that where it's up to, what's happening. I can pause it at any point in time. But the other big thing is that it now supports asynchronous processing. So in Creo 7, when this was introduced, I would run my topology optimization, and essentially I just had to sit there and let it run. I couldn't do anything else while that was running. So now it hands that off as a background process, okay? And I can go off and start doing other stuff, right? I can check in on the process manager to see where it's up to at any point in time, okay? And once it comes back and saying it's run, I can quickly jump and open that up and see what's happening, okay? So it gives me more options to continue working Creo while that stuff's running locally. Another new thing is the automatic envelope. So in Creo 7, I had to define those areas. I had to define what I want to keep, what I want to stay out of, and also the volume of material that I wanted to, play with, what the system could generate the result in. Okay, so that kind of, in some ways, that might defeat the purpose, right? You kind of want to say to the system, well, just give me anything, right? Go nuts on this, because I'm going to maybe additive manufacture this. So there's no limits. Okay. So what we can do now in Creo 8 is we can have the starting geometry automatically generate. Okay, so we can't have any manually defined information. We just define our bits we want to keep, and then we can just automatically generate a volume that we want to start to simulate or work with material. Okay, so if we do have any particular constraints, that's where we'd use our sort of keep out, our exclude bodies to define. Well, maybe we need a bolt to come down here onto this hole, so we need to make sure that we can get into it. So we'll have a look at that. Imran will show this in the demo. When it comes to, once we've run our optimization, we want to convert that back into a finished model. Okay, so basically that's an automatic one button click, and it uses style curves and the freeform surface tool to build that up. Okay, so one of the things was that those curves that it would create could be quite heavy. Okay, so there could be lots of points there depending on the intersections and everything that it found. There's some new tools in there to help work with and simplify down those curves and removing those unwanted points. Okay, so that's there for those curves, and this is also applicable inside ISTX, right? Because these curves it creates are essentially style curves for ISTX. So if you're working with ISTX, you've also got those same options. It's less likely that you'll create them in ISTX because you'll probably just create and click the minimum number of points to build your style curves. But it's if you are dealing with that, it is still available inside. Okay. When it comes to the reconstruction of the actual finished geometry, okay. So again, some enhancements to that, particularly around the parting line constraint now. So it will basically create a parting line in the definition, so an actual curve or a freestyle curve through that, and then fix the geometry to that to give you some better options. Okay. So this relates to some of the new options that came in Creo 7 for the freestyle feature in terms of draft connectivity. So we're reusing that in 8 now to give a more defined and better parting line on that. So the thing to remember is this GTO, you know, we don't have to come up with weird fanciful parts that we can only manufacture through additive. Okay, we can also define parting lines, so it is something that could be cast or injection molded or even machined. So kind of related to the to that as well is a new option for the minimum crease radius. Okay, so we can define that as another design criteria constraint. So essentially that sort of gives us smoother geometry. So when we define a minimum crease radius, you're basically saying how, how tight a bend or fold in it. So, if we didn't specify minimum crease radius, you could end up with sort of lots more ribs and things like that because it's got a lot more ability to define those sorts of shapes. But by increasing the crease radius, we end up with something a lot smoother. And maybe that's more aesthetically pleasing or applicable to what we want to have.